All right, today's notes are 2.1 functions, part 1. So first we're just going to define a function. You guys are pretty familiar with them, so this should all be reviewed today. A function can be said as f, which is a rule that assigns each element x in a set A exactly one element called f of x in a set B. So the symbol f of x can be read as f of x or f at x. And set A is the domain, the independent variable, or the input. So those are some words that may make more sense to you and you've heard many times. Those are the x values. And then set B is the range, the dependent variable, which depends on the other variable, and the output. So those are the y values or the f of x values. All right. So example number 1, analyzing a function. So it's just got 3 parts. Analyzing a function. So there's function f, which is defined by the formula f of x equals x squared plus 4. So part A is asking us to express in words how f acts on the input x to produce the output f of x. So it's just asking you to say what's happening in this function. So what we're going to put here is that you are square x squared plus 4, then add 4. That's what you're doing to x in order to get the output f of x. Okay, and then B says to evaluate f of 3, f of negative 2, and f of square root of 5. So remember that means f at 3. So when x is 3, what is the entire function's output? So we're going to do f of 3. You just substitute 3 in for x. Okay, so then you can rewrite it as f at 3 equals 13, because that's 9 plus 4. Okay, f of negative 2 equals negative 2 squared plus 4. And remember, negative times negative becomes a positive. So f at negative 2 equals 4 plus 4, which is 8. And then the last one, f of square root of 5 equals square root of 5 squared plus 4. Square root of 5 times square root of 5 is 5. So f of square root of 5 equals 5 plus 4, which is 9. Okay, so that's the answer there. And part C says find the domain and range of f. So, well, you can basically think about the domain. Let's start with the domain. The domain is the x values, and you can plug any x value in here, and it will work. You can square any value. So there's no limit there to what you can put in there. So it's all possible inputs, so we can evaluate it as the domain is all real numbers. So we can say domain, okay, that's the x values, is all real numbers. So you can write it like that. It's all real. Which you can also write as negative infinity to positive infinity, like that, okay? And then the range is all possible output values. But since every time you square x, so x squared, this always becomes a positive number, right? So it's any positive number plus 4. Okay, so the smallest number that x squared can be is 0, because 0 times 0 is 0. You can never have a negative answer there, plus 4. So the smallest value that y can be is 4. Okay, so the f of x needs to be greater than or equal to 4. because you'll never get an answer less than that. So you can go ahead and try that, but we're just talking through it. So the range, so you can write the range of f is, you can write it like this: any value of y when y, which is, that's f of x, it's the same thing, but y has to be greater than or equal to 4, just like that. Or you can write it like we did the other one with intervals: 4, including 4, up to infinity. So that's the range. Okay, example 2. Evaluate a function. So this is just more practice with evaluating. So the function is 3x squared plus x minus 5. Evaluate each function. So we're just going to go ahead and plug these in, show our work. So f of negative 2, let's move over here so I have some room. F of negative 2 equals 3 when you plug in negative 2 and square it, but then add negative 2 minus 5. So we just got to remember our negatives there. That's going to be 4 times 3, which is positive 12, minus 2 minus 5. So f at negative 2 equals 5. Just make sure you do your negatives correct there. Okay, and then let's do f of 0. So f at 0 equals 3, 0 squared plus 0 minus 5. So that's going to be 0 plus 0 minus 5. So f at 0 is negative 5. Okay, f at 4 is 3 times 4 squared plus 4 minus 5. That's 16 times 3, which I think is 48. And then plus 4 minus 5, which is basically just minus 1. So it's 47. You can check my work on that one. Okay, and then f to the 1/2. So f of 1/2 equals 3, and then you square 1/2 plus 1/2 minus 5. Okay, so this one is going to be, I'm just going to show a little bit more work here. This is 3 times 1/4 plus 1/2 minus 5. So this is going to be 3/4. And I know that 1/2 is the same as 2/4. And I know that 5 is the same as 20/4. So that's, this is going to be 5/4 and this is 20/4. So our final answer is negative 15/4, and then you can just leave it like that. All right, the last example today is a piecewise defined function, which you might remember, but this one's always the one that gets people the most. So a cell phone plan costs $39 a month. The plan includes 2 gigabytes of free data and charges $15 per gigabyte for any additional data used. Wow, throwback to when you didn't have unlimited data. So the monthly charges are a function of the number of gigabytes of data used. So this is a piecewise function. So cost is dependent on gigabytes used. So we're making cost the function, the output, and the gigabytes used is x. So our answer is going to be c of x, right? Every time you change x, your cost changes. Okay, so we actually need to write this function out. So in order to write this, we're going to write cost with at every x equals, and this is piecewise, so it's a rule, it's a different rule for each spot. So it's $39. So if x is between 0 and 2 gigabytes, right? So up to 2 gigabytes, you pay $39. Then you pay $39 plus $15 more for every gigabyte after the first 2. So we're going to subtract those first 2. Okay, so that's the second part of our equation. And this is what you use when you have more than 2 gigabytes. Okay, so you should be able to make a piecewise function out of that word problem given. And then from here we can find the cost if you only use 0.5 gigabytes, if you only use 2 gigabytes, and if you use 4. Okay, so let's start with each of those. So this first one, if you only use 0.5 gigabytes, that falls right here. 0.5 is between 0 and 2, so we're going to use C of 0.5 just equals $39. So you pay $39 for 0.5 gigabytes. That's what you just found, okay? And then if we did cost at 2 gigabytes, well, that still falls in this category up here. It's because X is, it's up to 2, including 2. So that actually is C cost at 2 gigabytes is also just $39. So $39 for 2 gigabytes. And then the last one is when C of 4, so that's when X is 4 gigabytes. So that falls down here in this bottom category where X is greater than 2. So actually this one we have to solve. So C of 4 equals 39, that original $39, plus $15 for every gigabyte over the first 2. So that's 4 gigabytes minus the first 2. And so that's going to be 39 plus 30. So C of 4 equals 69. So that was $69 for 4 gigabytes. Okay, so that was probably the one that you needed the most review on. Last example for today is finding net change. So let f of x equal x squared. Find the net change in the value of f between the given inputs. So for A, we have to find the net change from 1 to 3. So that's when x is 1 and when x is 3. So we are going to, this is the initial, this is the starting point, and this is the final. So we have to do final minus initial. So net change, is f of 3, that's the final, minus f of 1. And you just find the difference between the two answers. So that's going to be, it's just x squared. So it's just 3 squared minus 1 squared, 9 minus 1. So that's 8. And I'm going to write what I solved over here. Okay, and then the net change of f from -2 to 2. So remember, this is where we start, initial, this is where we end. So we need to subtract final minus initial to get the net change, the difference. So that's going to be f of 2 minus f of -2. And remember, f of x is just x squared, so we're just going to square minus -2 squared. Okay, 2 squared is 4, and then -2 squared is also positive 4. So our actual net change here is nothing, is 0. And that's it for today.